Module 6, graph systems of inequalities. So a system of inequalities is multiple lines on the same graph. So we are going to use arrows to help us find the solution. Remember to only shade your final solution. So we're going to start with a nice easier one here. We've got x is less than 3 and y is greater than or equal to -2. So we start with x is less than 3. Again, if there's only one variable, like we learned in Module 5, we know it's going to go either vertically or horizontally. X is less than 3 means we're going to go to 3 on the x-axis. Vertical, because we want a line that goes through it. And again, dashed, because it's less than. Again, we put in 0. Is 0 less than 3? Yes. So instead of shading, now we're going to draw arrows showing that if we were to shade just this one, we would shade left. We're going to do the same thing with y is greater than or equal to -2 on the same graph that we've already used. So we're going to go to -2, and we know it's a solid line because it's got the equal to symbol on it. And then we put in 0. Is 0 greater than -2? Yes. So this one is going to go up. And then we look at the section where it is being double covered. So in this case, the upper left, we are going to shade that. So again, you're only shading your final answer. Again, you don't have to color every box heavy and dark. Just show that you are shading this section or this region of the graph, if you will. All right, our next one, we are graphing two lines. So we'll start with the top one, 2x minus 3. Again, this is in slope-intercept form. So you start at -3, go up 2 over 1 is your slope. And we're drawing a solid line through those points. And again, using a straight edge so you have a nice straight line. Putting in 0 for both x and y, you get 0 is less than or equal to 2 times 0 is 0 minus 3 is -3. Is 0 less than -3? No. So we are going away from the origin. So whether you use 3 arrows, 4 arrows, 5 arrows, the arrows just help you show this is this side of this line. And now we're going to graph y is greater than -2/3 x plus 5. So again, you're going to go up to 5, down to over 3. And we're going to draw a dashed. Putting in 0 for both x and y. We get 0 is greater than -2/3 times 0 is 0, plus 5 is 5. Is 0 greater than 5? No. So again, we're going away from the origin, which in this case is the upper side. And then you are going to shade only the final solution, which is this quadrant over here. All right, our last one has two lines that are both in standard form. So both of these, you are going to have to convert this to slope-intercept form. So again, we're going to subtract 2x, and I'm just going to bring it over here to the right. So you got 4y is greater than -2x plus 8. Divide by 4 to get y by itself, and we get y is greater than -1/2 x plus 2. Again, we're going to go and graph this then. So +2, -1/2. Again, you only need 3 points. Use your straight edge. Again, we're drawing a dashed line. And when you go to put in 0, you go all the way back to the original problem, 0 for x, 0 for y, and we get 0 plus 0 is greater than 8, or in other words, 0 is greater than 8. which is no. So we are going to shade away. So again, drawing arrows away from the origin. Again, same process here. Going to subtract 3x from both sides, and we get negative 2y is less than negative 3x plus 6. Again, writing it in slope-intercept form. Divide by negative 2, so we get y, and then because we divided by a negative, we're flipping that sign. Negative 3 over negative 2 becomes positive 3 halves x. 6 divided by negative 2 is negative 3. So we're now graphing y is greater than 3 halves x minus 3. So we're going to go down to negative 3, up 3 over 2, up 3 over 2. Again, drawing a dashed line through those points, extending it all the way to the edge. Again, when we put in 0, you're going back to the original problem. So 0 minus 0 is less than 6. Well, 0 minus 0 is 0. Is 0 less than 6? Yes. So that one we are going towards the origin, which the origin is here. So we're going to the left, or upper left, if you will. And that means our final answer, the region where the arrows are pointing at each other, is this triangular wedge on top. Complete the rest of your practice problems to complete this module, and have a great day, everyone.